All right, welcome back to Algebra 2 with Mr. Lambright and Mr. Austin. Today we're going to be talking about lesson 3.3, which is graphing systems of linear inequalities. So we've already graphed some inequalities, and now we're going to be graphing systems. So the first question I'd like to go over, a vocabulary term, is when we speak of systems of linear inequalities, what is it we're talking about? Well, a system. Think of a system as not just a line, which is what we'd already graphed before, but we're talking about two or more inequalities. On the same graph. So now we've got more than one inequality on the same graph. And keep in mind, when we do inequalities, there's going to be shading. So now our shading could possibly overlap one another. And we'll talk more about that in just a minute. So let's get into what's a solution of a system of linear inequalities going to look like. Well, first of all, a solution is going to be an ordered pair. So it's going to be a point. And that ordered pair is going to be a solution of both of the inequalities. So it's an ordered pair that is a solution of both inequalities. And again, we're going to talk about what that looks like, but since we're shading again, we're going to be talking about an infinite number of solutions possibly. All right, so let's jump into it. Our first example today deals with two separate inequalities. The first one being y less than 2x plus 1. Second one, y less than or equal to negative x minus 3. First couple things I want you to realize is, one, these two are both in y form for us already, which makes it nice. So we're going to use our y-intercept and our slope to graph for both of these. The first one we're going to look at is y less than 2x plus 1. First thing I notice here is that it's not underlined, meaning it's not equal to. So I'm going to be putting a solid or a dotted line when I graph this. Let's start at positive 1. Positive 1 on the y-axis. From there, we're going to be going up 2 and over 1. And again, if you want to make more than one dot, that's fine. Up 2 over 1 again. Up 2 and over 1 again. And I might go down 2 and left 1 from the previous point, the y-intercept that we put on. And down 2 and left 1 again. I'm going to get this line nice and straight. So that's what it's going to look like. I know it's going to be dotted, so let's just go ahead and create that on here. There's my dotted line. Now, since this graph is less than, we're talking about all of the area below this graph. So I'm going to draw in some arrows just for now, showing us that the shading that we're going to be doing is actually below this line. All right, let's move to our next one. Y less than or equal to negative x minus 3. For this one, I'm going to use my y-intercept again. My y-intercept is going to be at negative 3, so 1, 2, 3. From there, I'm going to go down 1, right 1, because I'm a negative slope. So this line is going to be in this area. I'll go up 1, right 1. And this one we know is going to be a solid line. So as best I can on here, I'm going to draw in my solid line. I know my graphing's not great with this pen, but I'm trying the best I can here. And this time it's going to be less than also. So again, I think I'm going to use these yellow ones again. And I'm going to show you less than below this line also. This is where the shading would take place. So now I want to look at, when I'm shading this, when I'm shading them both at the same time, I want to look at where are the arrows pointing at each other. And the area that they're pointing at each other is where these two lines share that shaded region. And that area is located right here. And that's going to be the area that we want to color in. That's the region that would be shaded. That's where my solution would be found. Any point in that region satisfies both of these inequalities. And that's what it should look like. I recommend using either a colored pencil or something different other than your pencil to shade in. I think it just makes it a little easier to see. All right, let's move on to our next example. Well, the first one's in Y form, but the second one's not. So let's start with the first one. This one is less than or equal to, solid line, negative 3/4 x, that's our slope, plus 1. Let's start at plus 1. Go to plus 1, put our dot. We know we're going to go down 3 over 4, so 1, 2, 3 over 1, 2, 3, 4. There's our next one. I'm going to do it one more time, down 1, 2, 3 over 1, 2, 3, 4. And I might go up from this one, 1, 2, 3, 1, 2, 3, 4, so I can extend my line out. I know it's going to be a solid line, so I'm going to go ahead and draw in the best I can with my pen here. A nice solid line. Should look like this. And the shading for this, we'll use that yellow again, is going to be less than. So I'm going to draw my arrows that are going to go underneath this one. That's where I would shade. All right, so now I got to go to my second one, which is not in Y form, and I need to put it in Y form. So the first thing I'm going to do is subtract a 3x from both sides. So that's going to cancel those out, leave me with 4y greater than negative 3x plus 16. Lastly, I'm going to divide by 4. That's everything gets divided by 4. That's going to leave me with my Y form, which is y greater than negative 3/4 x plus 4. Now, right away, I'm noticing something. I'm noticing that we've got the same slope again as the other one. Interesting. Let's see what this is going to look like. Let's go up to 4. Put our dot. And from here, we're going to go down 3 and over 4. Down 3. Over 4. And I might go up 3 and over 4 from our first dot. That way I can draw a nice solid line that I now know has to be parallel to the other line. Drawing it the best I can on here. You've got two parallel lines. Now for this one, it also says less than. Oh, sorry, apologize. For this one, it's greater than. So we're going to be going above the line. Again, greater than, it's above that line. Well, interestingly enough, looking at this graph, I'm noticing something. I'm noticing that, first of all, this second line that I just made was solid. It should have been dotted. So I can go back in here and make that a dotted line. There it is. But now, looking at these two graphs after making my correction there, I'm seeing, hang on just a second, none of this shading is going to overlap. So what exactly does that mean when the shading doesn't overlap? Well, the answer to that question is that what I'm going to be writing in here is simply letting you know that these have no solution. Which makes sense because nothing overlaps as far as the shading goes. So this is an example of a no solution problem. All right, on to our next one. Both of these, again, are nicely put in Y form for us. So let's start with the top one. Let's go down to negative 3, put our dot. From there, we're going to go up 2 over 1, up 2 over 1, up 2 over 1. I'll go down 2, left 1, just to extend it a little bit the other direction. This is a dotted line. So we're going to be looking at a dotted line for this one. This is also greater than. So this time we're going to be talking about above the line shading happening. All right. Again, these arrows are just showing me where I would shade for that one. All right, my next one starts at positive 2. So I want to go up to 2, put my dot, that's my y-intercept. And then I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. And I'll go back to my y-intercept and go up 1, left 2, just to extend it. And this one's going to be a solid line. And for this one, it's less than. So the shading is going to take place below that line. And once again, we look, where are the arrows pointing toward each other? That is in this region right here. And this is where I would do my shading. All my shading takes place in this region of the graph. And that's where my solutions are going to be located. Any point in that shaded region where they intersect each other is where my answers are. All right, let's take a look at our next example. Now this one, you'll notice that neither of the inequalities are in y form. So the first thing I want to do is put them in y form. Let's start with the top one. The top one looks pretty easy. I think all I'm going to need to do is I'm going to go ahead and recopy up here my equation, negative x plus 3y greater than negative 6. First thing I want to do is I'm going to add x to both sides. So that'll give me 3y, because these cancel, greater than an x minus 6. Last step is divide by 3. Everything gets divided by 3 again. Those cancel and leave me my equation or inequality, y greater than, and I'm going to go ahead and put that 1/3 x, so I can see my slope, minus 2. And that's the first equation I'm going to graph. So let's go down to negative 2. Put our first dot. From there, I want to go up 1, right 3. Up 1, right 3. Go back to my y-intercept. We'll go down 1, left 3, just to put another dot on there. And I'm looking at this one is a dotted line because it's not equal to. There's my dotted line. The shading for this is greater than, telling me that the shading is going to be above this line. All right, let's do our one on the bottom. Well, it's nicely already in y form for us. So let's start our graphing. Let's go up to positive 1, put our first dot on the y-intercept. From there, I'm going to go up 1, right 3. Up 1, right 3. Here I'm going to go on the y-intercept, I'm going to go down 1, left 3, just to extend my line a little further. And I'm also noticing we've got the same slope again. This one's going to be a solid line. These two lines, once again, are parallel. For this one, it's a less than shading. So I'm going to draw my arrows. And clearly I can see that my arrows are pointing at each other. And for this graph, that means that all of my shading is going to take place in between these two lines. So clearly they do overlap, and I do have some solutions here. It's everything between these two lines. All right, let's take a look at example number 3. We're going to graph this system. Well, first of all, I notice that my first one is y less than or equal to 4. Well, I'm noticing that that one's a special one. First of all, let's go up to 4. Put our dot. Now, because it's only y less than or equal to 4, I got to remember this is a special one. This is a horizontal line, and it's solid because it's equal to. Since it's less than, the shading for this is below the line. All right? My next equation, I'm looking at this and noticing, hey, that's absolute value. Well, I remember absolute values are V-shaped graphs. I also remember a couple of different things. That is my H value. That is my K value. Together, they are my vertex point. Remembering that H is the one that lies, that tells me my vertex is going to be at positive 2. And then K does not lie to me. It stays 1. There's the vertex point. Let's plot it. Let's go up 2 over 1. That's where the vertex is going to be located on my V-shaped graph. Now, also remembering that the number that's located out in front here is my A value. And my A value gives me the slope of my V-shaped graph. Now, I look outside of that absolute value and I don't see anything. Keep in mind that that means when I don't see anything that A actually is 1. So from this dot that I made for the vertex point, I'm going to, also A is positive, so it's going to open up. I'm going to go from that vertex point up 1 over 1, up 1 over 1, and up 1 over 1. And then I'm going to go back to the vertex point, and I'm going to go up 1 and then left 1. Up 1 and then left 1 again, up 1 and then left 1 again. That's what my V-shaped graph's going to look like. It's going to open upward, like so. And this one is greater than. Greater than is going to mean that my shading is going to be greater than. It's going to be inside of this V shape. If I am below my horizontal line and above or inside my V-shaped graph, that means that I'm shading this small region right inside of here. All right, so let's continue. Now that we've seen several different examples of these, I want everybody to keep in mind that because we're talking about inequalities, a couple key points that I want to make just one more time is that you need to remember that when the inequality is underlined, we've got a solid line, and when it's not, it's dotted. I think it might be helpful to draw those arrows that I was showing you for greater than or less than so that you can see where those arrows point, and that way you can draw or color in the area where they intersect each other. So as you do this, remember that if you do not understand where to shade, you can pick a test point to make sure that you're shading in the right region.